Hello, welcome to Anybody Can Learn. Today we will learn a problem based on the KNN. So first let us understand the basic idea of the KNN. Suppose I give you several points on a graph. Some points are color blue and some points are color red. Now I give you one new point whose class is unknown, and the question is, should this new point be classified as a blue or red? KNN gives us a very simple idea. Look at the nearby points and see which class is more common among them. In other words, the points that are close to each other are assumed to have similar characteristics. For example, imagine you move into a new neighborhood and you want to know whether the neighborhood is mainly a student area or family area. You might look at the people or houses closest to you. If most of your nearby neighbors are student, you may conclude that your area is probably a student area. KNN works in similar way. It looks at the nearest neighbors of the unknown point. That's why the algorithm is called K nearest neighbor, where K means number of neighbors we are going to consider. Nearest means the closest point and neighbor means turning points around our unknown point. So KNN look at the K closest turning points and use them to predict the class of new point. So KNN means look at the K closest turning points and use them to predict the class of the new points. Now let us look at our classification problem. Suppose we have two classes, class A and class B, and we already have several training points. Each training point has coordinate and we know the classes of each training point. Now we receive a new test point and the class of this new test point is unknown, and our task is to predict the class for this new test point. Suppose for example our new test point is x is equal to 3, 3, and we have given a value of the k as k is equal to 3. Just now we see that k means consider the nearest points. So here we will need to find the 3 nearest neighbors of this test point. For this we will compare the test point with each of these training point. That means the test point x need to be the compare against all these training point. So for comparing, always remember that we need all the training points, and these comparisons or to find the nearest neighbors we will use a Euclidean distance formula to find the closest training point which are close to the test point. So we measure how close test points are using the straight line distance, that is Euclidean distance formula, and the formula is d of xp, x means test point and p is a training point, is equal to square root of x2 minus x1 square plus y2 minus y1 square. So let us calculate the distance between the test point x and the point p1. Let us see the point p1 is 1, 1. So d of x p1 is equal to square root of 2 minus 1 square plus 3 minus 1 square. So 2 minus 1 means 1 and 3 minus 1 is 2. So square root of 1 square plus 2 square is square root of 5 square. So the distance between the test point and a point P1 is approximately 2.236. We will calculate the same way to find the distance between the test point and all the 6 training points. So after calculations, we find the distance between the test point and the training point P1 is 2.236. Similarly, we calculate the distance between the test point and point 2. Training point 2 is 2 and distance between test point and training point 3 is 1. Distance between test point and training point 4 is 3.606. Distance between a test point and training point 5 is 4.243. Distance between test point and training point 6 is 5,000. Now we will sort this distance from the smallest to the largest. That means we will arrange the distance in their ascending order. So the smallest distance comes first, and which is a distance between the test point and point 3, which is 1. Then comes the P2 distance is a 2, and then come the distance from point P1, which is 2.236, and then the distance from the point P4, which is 3.604. Then comes the distance from point 5, which is 4.243, and finally the distance from point 6, which is 5,000. We have given the k as a 3. So we must take the first 3 points from our sorted list, because we want to find the 3 nearest training point from the test point. So the points selected are P3, P2 and P1. Now look at their respective classes. P3 class is class A, P2 have the class A, and P1 also belong to class A. So now understand the concept of majority voting. KNN classification normally uses majority voting. Majority voting means the class A receives 3 votes because all the 3 training points belong to class A, and class B receives 0 votes because no of the training point belong to class B. So majority voting means we will predict the class which has a more frequency. So we will predict the new test points belong to the class A. So mathematically this is expressed as y hat is equal to mode of y1, y2 up to yk, where y hat is the predicted class and mode means the value that occur most frequently. For example, let us see the example set of red, red, red and blue. Here the frequency of red is 3 and frequency of blue is 1. So the 3 is greater than 1, therefore red wins because it has a majority voting. Therefore the mode of this set is red. Similarly, in our example of class A and B, class A has 3 votes. So class A wins, and we will predict that the test point has a class A. So that means we predicted the class of test point as class A. Now understand why we call the KNN as a lazy learning algorithm or instance based learning algorithm. In our current example, to find the 3 nearest point, we must first calculate the distance between the test point and all the 6 points. That means we need all the training data for this prediction. Also, it is essential because it is essential to memorize the training data, and it does not create a complicated mathematical model during the training. So for calculating the distance between the test point and a training point, KNN need to memorize the training data, and during that process it does not create any mathematical model, but instead it look at the training points, and when the new points when a new test point arrives. So now remember that n means total number of training points and k means number of the nearest points considered for the predictions. So we are storing all the training points, all the training data in knn, and for predictions we are only using the k neighbors. So remember it like store all and select k. Now let us solve the question 1. We have a data set of 2000 points for a classification problem using a KNN algorithm. Now consider the following statement. Statement 1, if k is equal to 20, it is enough if we store any 20 points in the training data set. Statement 2, if k is equal to 20, we need to store the entire data set. Statement 3 is the number of the data points that we have to store increases as the size of k increases. And statement 4, the number of the data points that we have to store is independent of the value of the k. And the options given to us are statement option A, statement 1 and statement 3 are true statement. Option B, statement 2 and statement 4 are true statement. Option C, statement 1 alone is a true statement. Option D, statement 3 alone is a true statement. And option E is statement 4 alone is a true statement. Now let us analyze each statement. Statement 1 given is if k is equal to 20, it is enough if we store any 20 points. This statement is false because k20 means use 20 nearest neighbors. That doesn't mean to store the 20. Always remember KNN need to store all the training data points. Statement 2 is k is equal to 20. We need to store the entire data set. Yes, it's true because KNN need to store all the data points to find the nearest neighbors. Statement 3 is the number of the data points we store increases as k increases. This statement is false because increasing a k changes neighbors use, but it doesn't affect the point store. Statement 4, the number of the data points we store is independent of k. Yes, this statement is true. Store the same data set regardless of the k. So in our example, if n is equal to 200, that is the training data point given to us is 200 and k is equal to 20, k means consider the nearest neighbor. So they told us to consider the 20 nearest neighbors. So here we store the 200 data points, but we will use only the 20 nearest points to predict the class of our new test point. So let's revise some important formula. Euclidean distance is calculated by the formula square root of x2 minus x1 square plus y2 minus y1 square. And for classification we will use the formula of y hat is equal to mode of y1 y2 up to yk. That means predicted class is the class occurring most frequently among the k nearest neighbors. So mode means the number which has the more frequency. Now understand some important terms. So training point means a data point whose class is already known. Test point means a point which we want to predict the class. K means number of nearest neighbors to be considered, and neighbor means a training point close to the test point, and distance means measure how close two points are, and Euclidean distance is straight line distance between the 2 points, and majority voting is a class with the most votes win. Mode means most frequently occurring value. Tie means 2 or more classes receives the same number of votes, and classification is assigning a data points to a class. So the most important takeaway is calculate the distance to all, means calculate the distance between the test point and all the training point given to us, and select a k closest. K closest means select the k number of nearest training point and count the class, and from that nearest training point count the class of each nearest neighbor points, and majority wins means the most common class among these nearest neighbors will win. That means we will predict the class of the test point as the one which has the most frequency of the classes. Now consider the question 2. Suppose the blue and red points belong to two different classes. Both of them are the part of the training data set. The black point 2, 3, look at here, the black point 2, 3 also belong to the training data set, but its true color is hidden from our view. The black point 3, 3 is a test point, and the question is, how should we recolor the black training point, that is this 2, 3 point, if the test point is classified as a red without any uncertainty by KNN classifier with k is equal to 4. Use the Euclidean distance metric for computing the distance, and options are A blue, B red, and C insufficient information. Now understand the problem statement. So we need to find, we have given the two classes, blue class and the red class, and the test point is 3, 3. So consider this star as a test point, and we are using a k is equal to 4 nearest neighbor. Our training point 2, 3 is currently black, and the question is, what color should the black point to be given so that the test point is classified as a red without any uncertainty. We know the Euclidean distance, as it is a 4. You will use the formula of the Euclidean distance, d of AB is equal to square root of x1 minus x2 square plus y1 minus y2 square. We will use this formula for all the 8 points given to us, and we will calculate the distance from test point 3, 3 to every training point. Now first consider the blue point. So blue points are point 1, 3, 4, point 2, 2, 4, and point 3, 1, 3. So calculate the distance between the test point 3, 3 and point 1, 3, 4. So d is equal to square root of 3 minus 3 square plus 3 minus 4 square. So it is come to be the 1. Now calculate the distance between the test point and point 2 to 4. So it is a square root of 3 minus 2 square plus 3 minus 4 square. So its distance is 1.414. Similarly, calculate the distance between the test point 3, 3 and a blue point 1, 3. So it come to be 2. Now calculate the distance between the test point to the red point. So red points given to us are 3, 2, 4, 3, 4, 4 and 5, 3. So now calculate the distance between the test point and a point 4, 3, 2 by using the Euclidean distance formula, and it comes to be the 1. And the distance between a test point 3, 3 and a red point 4, 3 after calculating it with Euclidean formula is 1, and distance between a test point and a red point 4, 4 is 1.414. Similarly, the distance between the test point 3, 3 and red point 5, 3 is come to be the 2. Now calculate the distance between the unknown black point and a test point. So test point is 3, 3 and black point has a coordinate 2, 3. So distance between the test point and a black point is square root of 3 minus 2 square plus 3 minus 3 square. So it is a square root of 1 plus 0. So it comes to be the 1. So distance between the test point and a training black point is 1. Now let us summarize all the distances. So here all the distances are summarized. So we see that the smallest distance is 1, which is belong to 4 points, and the points are 3, 4 has a blue color class and its distance is 1, and point 3, 2 which has a red classifier and it is a 1, and point 4, 3 which has a class red and its distance is 1, and the point black 2, 3 the distance from the test point is 1. So we will use a k is equal to 4 as it is given in our example. So we need to find the 4 smallest distance from our table, and the smallest distance just now we see as a 1, and the 4 points which has the distance 1 from the test points are point 3, 4 with a class blue, point 3, 2 with a class red, and point 4, 3 with a class red, and point 2, 3 which is currently black. So this is a geometrical proof of our the nearest points. A circle of the radius 1 around the test points touches all these points, 4 points exactly. So these are our 4 nearest neighbors. Now we must decide the color of these black point at 2, 3, and there is a 2 possibilities that these black point belong to the class blue or class red. Now let us consider the possibility 1, that if 2, 3 becomes the blue. So if it becomes the blue, then our 4 nearest neighbors are now 3, 4 has a blue class, 3, 2 is red class, and 4, 3 is red class, and this training point 2, 3 is blue. So the blue class has 2 votes and red class has 2 votes. So there is a tie because we have 2 blue and 2 red. A tie means the classifier does not have a unique majority class. Neither class has more votes. Therefore classification is uncertain. But the question specifically asks to classify the test point as a red without uncertainty. Therefore coloring the black point blue is not accepted. So our case 1 is wrong. Now consider the another possibility. If point 2, 3 becomes the red. So if it becomes the red, then our 4 nearest neighbors become 3, 4 has a blue class, 3, 2 is a red, 4, 3 is red, and 2, 3 is red. So let us count. So blue has 1 count and red has a 3 count. So clearly the red has a majority because 3 is greater than 1. So our final conclusion is that the second case satisfies the condition of being classified as a red without uncertainty. Therefore the black training point should be color red. So our correct answer is option B, red. Thank you.